Now we start a next section of the chapter application to derivative, increasing and decreasing function. First of all, discuss what is an increasing function and decreasing function. Here you draw four geometrical representation of a function. First of all, we consider x1 and x2 are two consecutive 2 points, and their images are f of x1 and f of x2. Here, if x1 less than x2 implies f of x1 less than f of x2, then the function is said to be strictly increasing. In this case, here you select 2 points, again x1 and x2. Their images are f of x1 and f of x2. In this case, as x1 less than x2 implies f of x1 is greater than f of x2. If x1 less than x2 implies f of x1 less than f of x2, then the function is said to be strictly increasing. Then the function is said to be strictly increasing. If x1 less than x2 implies f of x1 greater than f of x2, then the function here f of x1 is y coordinate is greater than f of x2, and therefore function is said to be strictly decreasing. Here, similarly, here we take x1 and x2 also. Their images are f of x1 and f of x2. In this case, there is some point where x1 and x2 corresponding images are equal, that is f of x1 and f of x2 are equal. That is, if x1 less than x2 implies f of x1 less than or equal to f of x2, in this case function is said to be increasing, not strictly, is increasing. Similarly, here also, as x1 less than x2 implies f of x1 greater than or equal to f of x2, in this case function is said to be just decreasing, not strictly, is decreasing. Okay, these are some definitions. These are the definitions regarding increasing and decreasing functions. Just a fundamental definition. It's a very simple definition. Here you take x1 and x2, and similarly their images are also f of x2 here, and f of x1 is on the above the f of x, that is upper part of, that is f here f of x1 and x2. Here x1 is less than x2, but their image f of x2 is greater than f of x2, f of x, or f of x1 is greater than f of x2, not f of x2, f of x1 is greater than or equal to f of x2. Here there is some point where f of x1 and f of x2 are equal, so this function is said to be decreasing function. Okay, these are the definitions. Okay, it's a basic definition. Actually, here we discuss how to find increasing and decreasing function using derivative. That's the main section of this chapter. How to find the derivative, how to find the function, increasing and decreasing function using derivative. Here y is equal to, our definition says that y is equal to f of x is a continuous function. Y is equal to f of x is a continuous function, defined continuous and a differentiable function defined on an interval ab. Defined on interval ab. If f is said to be strictly increasing, then the condition is f dash x0 greater than 0 for all x0 element of the open interval ab. And f is said to be strictly decreasing, then f dash x0 less than 0 for all x0 element of the open interval ab. Okay, and f is said to be increasing, then in that case f dash x0 is greater than 0 for all x0 element of the closed interval AB, and f is to be decreasing. In that case, f dash x0 less than 0 for all x0 element of the closed interval AB. That's all. That's the definition using derivative. ഒരു ഇൻ്റർവൽ തരുമ്പോൾ ആ ഇൻ്റർവെല്ലിൽ ഫംഗ്ഷൻ സ്ട്രിക്ട്ലി ഇൻക്രീസിങ് ഓർ സ്ട്രിക്ട്ലി ഡിക്രീസ് ചെക്ക് ചെയ്യുന്നതിന് ഫംഗ്ഷൻ്റെ ഇൻ്റർവെലിനകത്തുള്ള പോയിൻറ്റ്സ് ഫംഗ്ഷൻ്റെ ഫസ്റ്റ് ഡെറിവേറ്റീവ് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുക. സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുമ്പോൾ വി ഗെറ്റ് എ പോസിറ്റീവ് വാല്യൂ, ദെൻ ഫംഗ്ഷൻ ഈസ് ടു ബി സ്ട്രിക്ട്ലി ഇൻക്രീസിങ്. അതേസമയം വി ഗെറ്റ് എ നെഗറ്റീവ് വാല്യൂ, ദെൻ ഫംഗ്ഷൻ ഈസ് ടു ബി സ്ട്രിക്ട്ലി ഡിക്രീസിങ്. ജസ്റ്റ് ഫംഗ്ഷൻ ഈസ് ടു ബി ഇൻക്രീസിങ് ഓർ ഡിക്രീസിങ്. ദാറ്റ് കേസ് നമുക്ക് ഒരു ഇൻ്റർവൽ തരുന്നത് ഒരു ക്ലോസ് ഇൻ്റർവൽ ആയിട്ടാണ്. കാരണം ക്ലോസിൻ്റെ അപ്പർ ആൻഡ് ലോവർ വാല്യൂ കൂടി നമുക്ക് കൺസിഡർ ചെയ്ത് പോകാം. ഈ റെയർ കേസ് മോഡൽ ഇൻക്രീസിങ് ആൻഡ് ഡിക്രീസിങ്ങിൻ്റെ ആയിട്ടുള്ള പ്രോബ്ലംസ് വളരെ കുറച്ച് പ്രോബ്ലംസ് മാത്രമേ ഉള്ളൂ. അപ്പോൾ ട്രിഗണോമെട്രി ഫംഗ്ഷൻസ് വരുന്ന കേസുകൾ മാത്രമേ ജസ്റ്റ് ഇൻക്രീസിങ് ആൻഡ് ഡിക്രീസിങ് ചെക്ക് ചെയ്യുന്നുള്ളൂ. ഓക്കെ, മെയിനായിട്ട് വി കോൺസെൻട്രേറ്റ് ഓൺലി സ്ട്രിക്ട്ലി ഇൻക്രീസിങ് ആൻഡ് സ്ട്രിക്ട്ലി ഡിക്രീസിങ്. എ ഫംഗ്ഷൻ ഇസ് ടു ബി സ്ട്രിക്ട്ലി ഇൻക്രീസിങ് ഇഫ് എഫ് ഡാഷ് x0 greater than 0 for all x0 element of open interval AB, and is to be strictly decreasing if f dash x0 less than 0 for all x0 element of open interval AB. Just a simple definition. Okay, now we discuss how to find increasing and decreasing function using problems. Okay, it's a very important section. Our first question, find the intervals in which, our first question is find the intervals in which the function f of x is equal to, the function f of x is equal to x square plus 2x minus 5, x square plus 2x minus 5 is strictly increasing or strictly decreasing. It's the first question. Find the intervals in which the function f of x is equal to x square plus 2x minus 5 is strictly increasing or strictly decreasing. Okay, now check how to find strictly increasing and strictly decreasing interval. Okay, first of all, our first step is, first of all we find f dash x. Derivative s square is 2x and derivative 2x is 2 and derivative minus 5 is 0. Then we put f dash x is equal to 0. That means 2x plus 2 is equal to 0. Therefore 2x is equal to minus 2, and that implies x is equal to, we get answer, minus 1. Now we form a real line. This is minus infinity and here is plus infinity. We put x is equal to minus 1 here. Therefore we get two part, that means two interval. Our first interval is minus infinity to minus 1, and our second interval is minus 1 to plus infinity. Okay, we get two intervals. Now we check ഏതൊക്കെ ഇൻ്റർവെല്ലാണ് ഫംഗ്ഷൻ ഇൻക്രീസിങ്, ഏതൊക്കെ ഇൻ്റർവെല്ലാണ് ഫംഗ്ഷൻ ഡിക്രീസിങ്. ഓക്കെ, first of all we consider the interval is minus infinity to minus 1, minus infinity to minus 1. Okay, our first derivative is 2x plus 2. Now we take a point lies between the interval minus infinity to minus 1. Minus infinity to minus 1 ഇടയ്ക്കുള്ള ഒരു പോയിന്റ് കൺസിഡർ ചെയ്യുക. Suppose you take minus 2. Then we put minus 2 to the first derivative, that is f dash minus 2 equal to, we get answer 2 into minus 2 plus 2 is equal to minus 4 plus 2 is equal to minus 2, which is less than 0. You know, a function is in an interval, suppose a function is to be strictly decreasing, then f dash x0 is less than 0 for all x0 element of the given interval. That means ആ interval ഒരു പോയിന്റ് നമ്മൾ ഫംഗ്ഷൻ്റെ ഫസ്റ്റ് ഡെറിവേറ്റീവ് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുമ്പോൾ ലെസ് ദാൻ ക്വാണ്ടിറ്റി കിട്ടിയാൽ then the function is to be strictly decreasing. f of x is strictly decreasing. f of x is strictly decreasing in the interval minus infinity to minus 1. Okay. Our second interval is minus 1 to plus infinity. Minus 1 കഴിഞ്ഞാൽ നിങ്ങൾക്ക് ഒരു പോയിന്റ് സെലക്ട് ചെയ്യുക. സപ്പോസ് ഇസ് ഈസി 0. 0 ഫംഗ്ഷൻ്റെ ഫസ്റ്റ് ഡെറിവേറ്റീവ് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുക. f dash 0 is equal to 2 into 0 plus 2 is equal to plus 2, which is greater than 0. അപ്പോൾ ഫംഗ്ഷൻ്റെ ഫസ്റ്റ് ഡെറിവേറ്റീവിലെ ഇൻ്റർവെല്ലിലെ പോയിന്റ് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുമ്പോൾ we get a positive quantity, then therefore our function is to be strictly, our function is said to be strictly increasing. Our function is said to be strictly increasing in the interval -1 to infinity. That's all. Actually, it's a very simple question. Try to do some 3 or 4 questions for getting a good idea. Okay. Okay, do one more question. Find the intervals in which the function f of x is equal to 2x cube minus 2x cube minus 3x square, 2x cube minus 3x square minus 36x plus 7 is strictly increasing or strictly decreasing. Find the intervals in which the function f of x is equal to 2x cube minus 3x square minus 36x plus 7 is strictly increasing or strictly decreasing. Okay. First we find f dash x, that is 2 into, the derivative s cube is 3x square minus 3 into derivative s square is 2x plus 36 into derivative x is 1, that is equal to 6x square minus 6x minus 36. Then we put f dash x is equal to 0. Our second step is put f dash x equal to 0. That is 6x square minus 6x minus 36 is equal to 0. ഇപ്പോൾ നമുക്ക് 0 സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുന്നതിന് മുന്നേ തന്നെ അത് ജസ്റ്റ് ഒന്ന് കോമൺ സെലക്ട് ചെയ്യാം. ഹിയർ 6 is common and therefore s square minus x minus 6. ഓക്കെ, വേണമെങ്കിൽ എനിക്കിതൊന്ന് ഫാക്ടറൈസ് ചെയ്യാം, പക്ഷേ ഈസി ആയിരിക്കും. ദാറ്റ് ഈസ് 6 ഇൻറ്റു ഫാക്ടറൈസ് മീൻ ആഡ് ചെയ്യുമ്പോൾ -1 മൾട്ടിപ്ലൈ -6 കിട്ടുന്ന 2 നമ്പേഴ്സ് ആർ -3 ആൻഡ് +2. ഫാക്ടറൈസ് ചെയ്യുമ്പോൾ x -3 ഇൻറ്റു x +2. ഓക്കെ. Okay, now we put f dash x equal to 0. That means 6x square minus 6x minus 36 equal to, that is 6 into x minus 3 into x plus 2 is equal to 0. 0 divided by 6 is 0. Then using 0 factorization theorem, either x minus 3 equal to 0 or x plus 2 is equal to 0. Therefore, x is equal to, we get answer 3 and x is equal to -2. These points are said to be critical points or stationary point or extreme points or turning point. There are different names are applied for these points. When we put f dash x equal to 0 and we get some values for x, that values are called turning point, stationary points or critical point and extreme points. Okay. Now we plot these points on a real line. Lower is minus infinity and upper is plus infinity. Here the lower point is -2 and next is 3. Therefore we get 3 interval. Our first interval is minus infinity to -2. Second interval is -2 to 3. And third interval is 3 to infinity. Okay. Now we collect each interval. Our first interval minus infinity to -2. Then we select f dash x. What is f dash x here? 6 into x minus 3 into x plus 2. ഒരു പോയിന്റ് കൺസിഡർ ചെയ്യാം. ആ ഇൻ്റർവെല്ലിൽ ഒരു പോയിന്റ് കൺസിഡർ ചെയ്യുക. സപ്പോസ് -3. ആ -3 ഫംഗ്ഷൻ്റെ ഫസ്റ്റ് ഡെറിവേറ്റീവ് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുക. നമുക്ക് വാല്യൂസിന് ഒരു പ്രാധാന്യമില്ല. ഫംഗ്ഷൻ്റെ ഫസ്റ്റ് ഡെറിവേറ്റീവ് കൊടുത്തിട്ട് കിട്ടുന്ന വാല്യൂസിന് യാതൊരു പ്രാധാന്യം കൊടുക്കുക. വി കൺസിഡർ ഓൺലി സൈൻ, പോസിറ്റീവ് ഓർ നെഗറ്റീവ്, ദാറ്റ്സ് ഓൾ. 6 is always positive. When we put a -3 to the factor x -3 we get a negative quantity, so negative. -3 plus 2 is also negative. That is plus into minus we get answer greater than 0. That means our function is strictly increasing. Our function is strictly increasing in the interval -infinity to -2. Now we consider the second interval -2 to 3. You take any point, it's a 0, is an easy point. 0 is an element of -2, 3. Put f dash 0, find f dash 0, sorry. 6 is always positive. 0 minus 3 is a negative quantity. 0 plus 2 is a positive quantity. Plus into minus into plus, we get less than 0 and therefore our function is strictly decreasing. Our function is strictly decreasing in the interval minus 2 to 3. Now we check in the interval 3 infinity. 3 infinity. 3 infinity. You take any point lies between 3 to infinity. 3 infinity take 4. 4 is an element of 3 infinity. Here f dash x is, here what is f dash x? 6 into x minus 3 into x plus 2. Find f dash 4. 6 is always positive. 4 minus 3 is also positive. 4 plus 2 is also positive. That means it's greater than 0. And therefore our function is strictly increasing. Our function is strictly increasing in the interval 3 to infinity. Okay, now last we combine to form our function f of x is strictly increasing. Our function f of x is strictly increasing in the interval minus infinity to minus 2 union 3 to infinity, and strictly decreasing in the interval minus 2 to 3. That's all. Okay, actually it's a very simple question, but it's also a very important question. Okay, now we'll discuss one more question similar to this type. Next question is question number 3. F of x is equal to, find the intervals in which the function f of x is equal to minus 2x cube minus 9x square minus 12x plus 1 is strictly increasing or strictly decreasing. First of all, we find f dash x, that is minus 6x square minus 18x minus 12. Then here minus 6 is common and therefore x square plus 3x plus 2. On factorizing this second degree, we get answer x plus, adding 3 multiply 2, we get answer x plus 1 into x plus 2. X plus 1 into x plus 2. Okay. Now we put f dash x is equal to 0. That implies minus 6 into x plus 1 into x plus 2 is equal to 0. 0 by minus 6 is 0. By using 0 factorization theorem, we get answer x is equal to minus 1 and x is equal to minus 2. These 2 points are said to be critical points or stationary points or extreme points. Now plot these points on a real line. Is a minus infinity, is a plus infinity. Here the lower value is minus 2, then minus 1. We get 3 interval. Our first interval is minus infinity to minus 2. Second is minus 2 to minus 1. And third is minus 1 to infinity. First we consider the interval minus infinity to minus 2. We take a point minus 3 lying between minus infinity to minus 2. Our first derivative become, what is the first derivative here? Minus 6 into x plus 1 into x plus 2. We put a minus 3 to the equation, to the first derivative, that is f dash minus 3. Minus 6 always, negative. Minus 3 plus 1 is negative. Minus 3 plus 2 is negative. Negative into negative is less than 0. And therefore f of x is strictly decreasing in the interval minus infinity to minus 2. Our second interval is minus 2 to minus 1. Here you take any point, that is minus 1.5. Therefore f dash minus 1.5 is equal to minus 6 is always negative. Minus 1.5 plus 1 is negative, minus 1.5 plus 2 is positive, and therefore which is greater than 0. Because negative into negative is positive, into positive answer is positive, is greater than 0, and therefore our function is strictly increasing. Our function is strictly increasing in the interval minus 2 to minus 1. Minus 2 to minus 1. And last we consider the interval is minus 1 to plus infinity. That is 0. It's very easy to find the first derivative. That is f dash 0. F dash 0 means minus 6 is always negative. 0 plus 1 is positive. 0 plus 2 is also positive, which is less than 0, and therefore our function is strictly decreasing. Our function is strictly decreasing in the interval minus 1 to infinity. And last we write our main function f of x is strictly decreasing. Our function is strictly decreasing in the interval minus infinity to minus 2 union minus 1 to infinity, and strictly increasing in the interval minus 2 to 1. Sorry, minus 2 to minus 1. That's all. Okay, these are some very easy questions. It's a very simple question. Now we discuss one more question using this concept. The next question is, let I be any interval. Is our NCERT question, our exercise question 6.2, question number 15. 6.2, question number 15. 6.2 exercise, question number 15. Okay, if you have any doubt in the question, please refer 6.2, question number 15. Our question is, let capital I be any interval disjoint from minus 1, 1. Prove that the function f of x is equal to x plus 1 by x. X plus 1 by x is strictly increasing on I. Here I means, here what is I? I is any interval disjoint from minus 1, 1. Okay, before that, first of all, we find f dash x. You know, x derivative is 1 and 1 by x derivative is minus 1 by x square. Then for finding critical point, put f dash x is equal to 0. That implies 1 minus 1 by x square is equal to 0. That is minus 1 divided by x square is equal to minus 1, and therefore x square is equal to 1. X is equal to, we get answer, the critical points are plus 1 and minus 1. Now we plot these points to a real line, that is minus infinity to plus infinity, and the points are minus 1 and plus 1. Now our question says that I be any interval disjoint from minus 1, 1. That means here there exists 3 interval part. Our first part is minus infinity to minus 1. Second part is minus 1 to plus 1, and third part is 1 to infinity. Here I means disjoint from minus 1, 1. I is an interval disjoint from minus 1, 1. That is minus 1, 1 എന്നുള്ള interval avoid ചെയ്ത് balance portion ആണ് ഇവിടെ I ആയിട്ട് mean ചെയ്യുന്നത്. I mean actually here I means I implies the minus infinity to minus 1 union 1 to infinity. Now here we have to prove that given function is strictly increasing. Our function is strictly increasing on this interval. Okay, now we select the first part, minus infinity to minus 1. We select minus 2. Okay, therefore f dash, here f dash x is equal to 1 minus 1 by x square, and therefore f dash minus 2 is equal to 1 minus 1 by minus 2 square is 4. That is 4 minus 1, 3 by 4, which is greater than 0, and therefore our function is strictly increasing. Our function is strictly increasing in the interval minus infinity to minus 1. Now the second interval, we consider the interval is not minus 1, 1 to infinity, because here we have to prove that given function is strictly increasing on I. Here I means minus infinity to minus 1 union 1 to infinity. So we select the next interval is 1 infinity. You take any point lying between 1 to infinity. It is suppose you take a 2. It's a very easy. Now put find f dash 2, that is 1 minus 1 by 2 square is again 1 by 4. 4 minus 1 we get answer 3 by 4, which is greater than 0, and therefore our function is strictly increasing. Our function is strictly increasing in the interval 1 to infinity. Okay, and therefore our function is strictly increasing. Our function is strictly increasing in the interval minus infinity to minus 1 union 1 to infinity. That is, f of x is strictly increasing. Our function f of x is strictly increasing on I. Here I means minus infinity to minus 1 union 1 to infinity. That's all. It's a very simple question also. Okay. Now discuss one more question using this concept, increasing and decreasing. The next question is, prove that the function f of x is equal to, prove that the function f of x is equal to, f of x is equal to x square minus x plus 1. Prove that the function f of x is equal to x square minus x plus 1 is neither increasing, neither strictly increasing nor strictly decreasing, neither strictly increasing nor strictly decreasing on minus 1 1, on minus 1 1 is actually 6.2 exercise question number 11. Question number 11. Question number 11. If you have any doubt in the question, please refer the NCR test 6.2 exercise question number 11. Our question is, prove that the function f of x is equal to x square minus x plus 1 is neither strictly increasing nor strictly decreasing in the interval minus 1 1. So first of all we find f dash x. You know the derivative x square is 2x and x derivative is 1. Then we put f dash x is equal to 0. That implies 2x minus 1 is equal to 0. Therefore 2x is equal to 1, and therefore x is equal to, we get answer 1 by 2. Actually നമുക്ക് ചെക്ക് ചെയ്യേണ്ടത് -1 1 ഇടയ്ക്കുള്ള ഇൻ്റർവെല്ലിൽ ഫംഗ്ഷൻ ഇൻക്രീസിങ്ങോ അല്ല ഡിക്രീസിങ്ങോ അല്ല എന്ന് പ്രൂവ് ചെയ്യാനാണ്. സോ നമുക്ക് ഇൻ്റർവെല്ലിൽ കൺസിഡർ ചെയ്യുമ്പോൾ -1 to 1 കൺസിഡർ ചെയ്ത് ഇതിനിടയ്ക്ക് ഈ 1 by 2 വരിക. സോ വി ഗെറ്റ് 2 പാർട്ട്. -1 ഇടയ്ക്ക് x is equal to 1 by 2 എന്നുള്ള ക്രിട്ടിക്കൽ പോയിന്റ് സെലക്ട് ചെയ്യുമ്പോൾ വി ഗെറ്റ് 2 ഇൻ്റർവെൽ. അവർ ഫസ്റ്റ് ഇൻ്റർവെൽ ഈസ് -1 to 1 by 2. Okay, -1 to 1 by 2. You take any point lying between -1 by 2, 1 by 2, it takes 0. F dash 0. What is f dash 0? F dash x is equal to 2x minus 1, and therefore f dash 0 means 0 minus 1 is equal to -1, which is less than 0, and therefore f of x is strictly decreasing. F of x is strictly decreasing in the interval -1 to 1 by 2. Our next interval is 1 by 2 to 1. You take any point. Suppose 1 by 2 നും 1 നും ഇടയ്ക്കായിട്ട് നമുക്ക് ഇഷ്ടമുള്ളൊരു പോയിന്റ് എടുക്കാം. 3 by 4 കൺസിഡർ ചെയ്യാം. 3 by 4. Okay, 3 by 4. Now f dash 3 by 4 is equal to, f dash 3 by 4 is equal to 2 into 3 by 4 minus 1 is equal to 3 by 2 minus 1. That is 3 minus 2. 3 minus 2 is 1 by 2, which is greater than 0. That means our function f of x is strictly, our function f of x is strictly increasing. Our function f of x is strictly increasing on 1 by 2 comma 1. That is in the interval -1 to 1. Our function is not രണ്ട് പാർട്ടും നമുക്ക് രണ്ട് ഇൻ്റർവെല്ലിലും ഇൻക്രീസിങ് ആയിരുന്നെങ്കിൽ in the interval -1 to 1 function is said to be strictly increasing. Suppose -1 to 1 1 by 2 ഡിക്രീസിങ്ങും 1 by 2 to 1 ഡിക്രീസിങ് ആയിരുന്നെങ്കിലും ഹോൾ ഇൻ്റർവൽ -1 to 1 നമുക്ക് സ്ട്രിക്ട്ലി ഡിക്രീസിങ് പറയാം. ബട്ട് ഇൻ ദ കേസ് ഫസ്റ്റ് ഹാഫ് is strictly decreasing and second half is strictly increasing, and the whole interval you get answer f of x is neither strictly increasing nor strictly decreasing. Therefore the interval -1 1. Therefore our function is neither strictly increasing, neither strictly increasing, neither strictly increasing nor strictly decreasing, nor strictly decreasing, nor strictly decreasing in the interval -1 to 1. That's all. Okay. Now the next video we will discuss some special problem regarding the topic increasing and decreasing function. That's all. Bye.